very good afternoon, all. We have gathered for yet another interesting ecotech talk of exneco today. And we have with us Dr. Soumen, who is scientist at Inter-University Accelerator Center. Dr. Carr has been doing research for past 26 years in the field of superconducting magnets and cryogenics. Presently, he is leading a team of IUAC to develop India's first indigenously designed whole-body MRI magnet system. When it comes to research, he is a pure gem, and we are honored to have him with us today. Our topic for the day is Advancing Sustainable Innovation in MRI Machines, a Way for Green Healthcare. We will be talking about reducing carbon emissions in MRI machines and the sustainable innovations done in this field in today's EcoTech Talk. We at exneco are proud to have him for our EcoTech Talk. exneco stands for Exploration, Networking, and Collaboration. And we are trying to build a platform for sustainable enterprises for the common good. Myself, Shrestha, and I'm the host for the day. Welcome, Dr. Kaur, for today's EcoTech Talk. My first question to you is, what is the role of MRI in healthcare system and what is the present scenario in India?
So, thanks for a nice introduction and a brief introduction. So, MRI, MRI is one of the most costly diagnostic tool, and generally, in patient needs to know that what is the abnormality in their body. So, there are different kind of a diagnostic tools are available presently, like CT scan, like X-ray is one of them, and MRI is also one of them. But MRI, so the radiologists see when they can see basically clear images between a abnormal tissue and normal tissue, then it is easy for them to easily make that diagnosis. So any diagnostic tool which gives the highest level of clarity between a normal tissue and abnormal tissue, so that will make the radiologist make easy to take the decision what kind of disease or what kind of abnormalities he or she is having in her body, in his body. So MRI is one of the such clinical diagnostic tool, but it's a costliest tool also. That means to run this machine also you need to spend a lot of money on that one. So that's why if you see, doctor initially suggests to do an X-ray. If they get all the information from the X-ray, then it's okay. If they don't get, they will ask go for a CT scan. If they don't get the information in the CT scan, then they will ask for a MRI machines. So because MRI gives the highest level of clarity between the normal tissues and abnormal tissues, and that is the basically the radiologist one. But in India, if you see, in most advanced countries, most of the advanced countries, per million of populations, like 10 lakh people, if you see, there are 10 to 30 MRI machines in advanced countries, in developed countries.
Okay.
Okay, 10 to at least 10 machines, at least there will be 10 machines per 10 lakh populations. But in India, it is hardly 2 or 2.5 machines per 10 million of populations.
Okay.
So it's a very low number, considering the country like India is a huge low number.
Yeah.
And in addition, yes, so in addition, the distribution of MRI scanners are not uniform. It's a very city-centric. That means you will get lot of MRI machines in the metro cities and then maybe tier 2 cities. But if you go to the little bit interior or tier cities, tier 4 cities, you will not get an MRI machines. That means if you are in Delhi, you will get plenty of machines in Delhi. But if you just go 100 kilometers either directions from Delhi, you will hardly see any MRI machines. So that's another problem with the MRI. And it's a very costly machine. So that's why you don't see them in a very frequently in a remote places or in any tier 2, tier 3 cities. And presently there is no manufacturer of MRI machines in India. So yearly we roughly imports almost like 3,000 crores worth of MRI machines to India. So there are three or four countries: US, UK, and then Japan and China. These are four countries which makes the MRI machines. So India, we are getting from all these four countries basically the MRI machines. So India needs a thousands of MRI machines actually in next few years, which is only possible when you indigenize them. That means you design everything and build at India. So then the cost can go down, and when the cost will go down, definitely the penetrations of these machines to the interior area will increase definitely.
Yes,
So
definitely.
that's the present scenario of MRI machines, and because it's a very costly machine, so that's why MRI, the cost of the scan is also high. So that's
Yes.
another. So accessibility is less. So it's costly. It's not cheaper. So you have to make cheaper, make it too accessible also. So this
Yes,
is the present
definitely.
scenario of the
Yeah. So
yes.
our country needs a lot of these machines, and it's really good that research is being done in this area. So my next question is, what are the current environmental impacts of MRI machines, and why is there a need for sustainable innovation in the area?
So if you see that MRI uh, machines definitely in the healthcare sector, you have to balance both. Like the balance both in a sense ki what kind of benefit it is giving to the human mankind, and another is the what kind of environmental impact you are you are generating or you are
Yes.
making impact. So
Yes.
it's a balance
Huh.
basically. This it cannot go in a one directions only. So while you have to take care of your patients gradually, at the same time you need to also take care how you are basically reducing that energy footprint, basically the carbon footprint or environmental impact. So MRI machines is one of the most basically energy guzzler machines, and that means it takes lot of power when the machine runs. So so if you see in the totality, it may not consume so much energy, but if you see that individual machines, you can see out of this healthcare or diagnostic machines, it takes a huge amount of energy. That means you are making more carbon footprint basically on this one. So definitely it needs huge innovations uh, in this area also, where the carbon footprint or energy consumptions can be reduced gradually without compromising the diagnostic part. You can't compromise the main objective of the any diagnostic tool. So without compromising with the basically diagnostic part or the quality of the diagnostic, you can do innovations, or people are doing innovations, and it also need of the hour actually to innovations to
Yes.
reduce the carbon footprint in this
Yes.
area also.
So that's a really good initiative. So, how the healthcare sector is, contributing to CO2 emissions, and what measures are being implemented to reduce them? So, if we look at the healthcare sector as such,
So if you see healthcare sector overall, healthcare sector is very big. It is not about the MRI machines.
yeah,
It is the medicine production, also production of the pharmaceutical industry. It is the basically all diagnostic machines, all therapeutic machines. So diagnostic part is one sector of the basically radio section of the healthcare, but you have multiple section of the healthcare.
yes,
Patient care is another one. So when patient is in ICU, that also consume a lot of powers. So when you are making a medicines, that also take a lot of power. Then so there are many section of this healthcare sector. Out of this entire carbon footprint, if you see, including all overall, healthcare contributes 5 to 10% emission.
okay,
Healthcare, it is the
okay,
overall healthcare,
healthcare
and
alone.
out
Okay.
So healthcare alone takes 5 to 10% typically, and the carbon emission contributes. And out of that 5 to 10%, that 10% out of that 10%, 10% actually is by the diagnostic tool, radiological diagnostic tools.
Okay,
That
that
means
is
the
very
X-ray,
high.
CT scan. So, so X-ray, CT scan, and the MRI, all these machines actually, the 10% of the
Total
mm,
healthcare.
to- total healthcare. So
Yeah.
total healthcare is again 10% of the total carbon emission of the basically including all things, anything. So total carbon emission. So that is the typically uh, carbon emission we are doing for the diagnostic part. So it's a typically 10% you can say, and there are a lot of measures. So I think people are extensively working on how to minimize this overall carbon footprint.
Okay.
And one thing you also remember, there are two, so the carbon footprint or energy consumption, what we call, there are actually two major components.
Yeah.
So, so directives means suppose one diagnostic tool you have installed in the suppose one MRI machine you have installed in the hospital. So one direct cost is that what is the operational cost when it is running in the hospital? So that's a direct cost. That means that is basically the hospital is consuming electricity power, and ultimately you are generating some kind of a carbon footprint in there. But there is another part which is a major in most of the cases, which is the indirect basically the carbon footprint, which is that means since the so you have built the machines
Yes.
somewhere. So you have consumed a lot of material, you have used a lot of components, a lot of materials. Okay, so the fabrications, and once you build it, then you have transported it uh, at some places on the
Yes.
hospital or diagnostic center. So all this basically, if you see the entire life cycle, so you
Yes.
have to see in a holistic manner, in a totality, how each and every aspects you need to identify where you can, and people are actually working because ultimately energy is you need to pay for the energy.
Yes.
So so anything you can basically, so everybody is putting efforts to minimize those components where we can reduce this energy consumption. So indirectly, it will reduce the basically that carbon footprint also, the carbon emission also. So
Yes.
these efforts are also going on.
Okay,
Yes.
that's great. So now, like apart from reducing the energy consumption, what materials or components in MRI machines can be made more eco-friendly?
Yes, this is a good question. In fact, so there comes uh, in continuation of my previous answer. So if you see the entire life cycle, starting from the manufacturing of the component and manufacturing of materials. So in any diagnostic component needs a different kind of materials, a lot of plastics, maybe a lot of insulating material, a lot of consumable material, a lot of gases, liquid, or maybe a lot of metallic materials. So you need say huge number of materials and a lot of components, a lot of electronic components. So you need to see that basically each and every component, uh, how you can make those components more eco-friendly. So each and every component. And another thing, how you can minimize the component. Suppose one machine needs a particular, I'll just give a very small examples. Suppose you need a 2 ton of stainless steel. Just I'll give an examples. Now, if you can reduce that weight of the stainless steel 1 ton, so that means you are reducing. So that means you need a less energy to produce that 1 ton of stainless steel.
Yes.
Okay. So in that way, without compromising the quality of the machines or the functionality of the machines, so these optimizations are people are doing actually, and it is needed
Yes.
because ultimately you need to reduce the cost. Cost can only be reduced when your energy consumption is reduced. So by that way, you are basically you can also make it cost effective and less carbon footprint. So people are looking where each and every component or each and every materials, how they can be made more eco-friendly. Okay, so it's a, like a reduce and then reuse and recycle
Recycle,
basically.
yes.
So yeah,
Definitely.
these
The
three
three
words.
R.
So three R basically. So and if you
Yes.
can reduce it, the material, and you can reuse it. So once you sometimes people scrap it something. So if that can be used it, okay, and they can be recycled also. That means again you can take back to them basically after recycling. So all these things I think people are working on this one, and this will make basically more eco-friendly, and uh, you will be making it less carbon footprint actually.
Yes, yes, definitely. So this is much needed, and it's good that a lot of research is being done in this direction. So how can the selection of materials used in MRI machines impact their sustainability and overall environmental footprint?
Yes. So this is again
We have
uh,
discussed
yes.
some.
So selection of materials. So that's why and when you design this kind of a complex diagnostic tool, so from the very beginning you need to take care of this environmental sustainability. So that's one of the prime objective, because once you build it without basically taking care from the very beginning, so once you build the machines and then you are calculating how to optimize them, it becomes much more difficult. So
Yes,
if from the since the inception, if you can start working, okay, how I can make each and every component eco-friendly, and how I can basically each and every component I choose that is a sustainable, and that gives the minimal basically footprint, carbon footprint. So that will and people are doing now actually. So initially it was not a when the MRI machines was developed at the beginning, maybe 90s or something, this was not of the of a part of the research basically. So
yes,
their main objective was to develop the machines and how they can create a meaningful image or clinical grade image. So that was the prime objective. So now for last I think 10-15 years, people are working how each and every material can be optimized, their usage can be optimized, their operation can be optimized, so that you can make it more eco-friendly way and more sustainable way. In fact, one examples I can give you, like country like in India. So because you, as I discussed that we don't have a wide access of high-tech healthcare in the remote areas. So suppose you have a mobile diagnostic van, and that is moving around the district or local healthcare centers. But the problem is that power. So if you can generate the power through the solar, because we are a tropical country, so
yes,
you get a sun, you have a huge sun power, you can use it. So suppose that mobile van uses a solar power, renewable energies. So that makes your basically the accessibility also increases, and the dependency or the conventional power is also basically reduces, and by that way effectively you are also reducing the carbon emissions also, because
yes,
you are not uh, basically generating carbon while producing the power. Otherwise we produce
yes. This is
the
very
because the,
interesting. Yes.
so that's the thing, basically one of the
Yeah.
uh, primary I think people are working on these directions also, to make it a more eco-friendly in that directions.
Yeah.
Yes.
So one another interesting question, can advancements in MRI machine design lead to cost savings for healthcare institutions while promoting environment sustainability? So what role does design play in all this?
Yes. So as I told you, if you design plays a huge role. Once you build it and then you ask to make it energy efficient, it's not a very good idea. So from the very beginning, when you are designing any systems, if you take at each part of your development, if you take a energy efficient method, each and every component, then ultimately when it comes the product, it will be much more energy efficient systems. So now, in fact, people are working in a in that cost saving. So in MRI machines, uh, typically in one machines, one scan almost 17 kilo carbon emission. Okay, and while CT scan typically 9 kilo carbon
Okay.
emissions. One, okay, and this
Uh-huh.
is the per scan I'm telling. It is the
So that
per
is
scan.
very high.
Yes, high. So, but the benefit it's giving. So that's why
Yeah,
again coming back to that
definitely. A
one,
balance
the
has to
kind
be
of
there.
balance has to be there. But still, people are trying to minimize those carbon emissions. So there are different ways you can basically do the cost saving. So the MRI machines, one of the typical requirement of the MRI machines, uh, it is there are a lot of component in MRI machines. Some of the components are used during the scan only. Some of the component of the MRI remains permanently on. Whether it's a there is a scan going on or there is a holiday, it doesn't matter. All the
Okay.
time it remains on.
Okay.
Some component of the MRI, and
Okay.
especially heart of the MRI, which is a magnet, superconducting magnet, which is maintained at minus 260 degree 8 centigrade roughly at that
Okay.
temperature. So to maintain that to minus 268 degree centigrade, you need some kind of a refrigeration system is going on all the time
Excellent. Yeah.
in the MRI machines. So whether it's you are doing any scan or not, you are not doing any idle conditions, it is sitting in idle conditions, it doesn't matter. All the time it has to be maintained. But there are a lot of power also goes when basically doing the scans also.
Yes.
So one is you have a constant power continuously you have to give. Another thing may vary depending on the kind of scan people can give.
Yeah.
Now, to reduce the power consumption, people are working on many aspects here. One is that there is a if you see the scan, there is a ideal uh, so some part of the day. So if you 24 hours, maybe one third of the day the machine is not used. So if you see the most of the diagnostic tool, they will not be used maybe night to till early morning.
Yes.
They'll not be used. But
Yes.
most of the time they remains on.
Yeah.
So remains on, and that takes a huge amount of power when it's an ideal condition also. So always, and that part is a non-productive part. Basically, you have a you because you are not generating any scan, you are not doing anything. So it's a non-productive energy consumptions. So people are working on this one, how to reduce this non-productive energy consumption. That means, can I put off some of the things during there is when there is no scan or during the night hour? Can I put it off, or can I do it cyclic on? That means if you don't scan it for a certain period, it will automatically shut off, and then after maybe half an hour or 1 hour, depending on the requirement, it will automatically put it on, basically. So by that way, you can basically reduce the energy consumption also in the MRI machines, and people are doing this one. So how basically you can how you can mm, make all this entire from designing state to the operational state. So each and every state, how you can make them how you can make them energy efficient, and each and every step, so that people are working. And uh, and so you can do basically when machine is on, you can put it on. When machine is there is no idle, no scan is going on, some part of the component, some part of the machines you can put it on, put it off, basically. So by that way you are reducing the energy, basically you are reducing energy consumption, and by that way you are making it is more sustainable, basically, because less environmental footprint you are generating. So that's I think the one of the major tasks people are doing presently, and this is part of the research also, how to make it in a smart, basically. So they are calling it a smart powering, uh,
Yes. Very
smart
true.
powering.
That
So
is a
smart
very,
power.
yeah, and that's in fact a very good input. In fact, if we look at it, there's no the better it's better that we do not use the energy when the machine is not working or it's not being
Hmm.
used, and it's a good research being done in this direction. So now, when we talk about the initiatives taken by the government, what are the initiatives taken in this direction? And what do you think needs to be further done so that these machines can be developed in a more sustainable, eco-friendly, as well as energy efficient manner?
Yes. So government actually like the we are so the if you recall my first answers, so India needs a huge amount of
Yes.
machines first,
Yes.
machines, and those machines are basically it is only possible when you have a indigenization. That means you have a production facility in India and you have
Yes.
indigenous designs, because so the government, the Ministry of Electronics and Information Technology, in fact, they have they have so the project we are doing, this is funded by them. So knowing them that it's a very complex machines, so they have asked, can we indigenously design and basically make it more affordable. So indigenously design, indigenously fabricate in India, and then we can be more it can be basically it can be made to more accessible to this one. So there are four institutes are working. IUAC is making heart of the machines, which is basically the magnet part. Then Samir, there is institute inside IIT Mumbai under MIT, that Ministry of Electronics and Information Technology. So they are taking care of all the RF electronics and all these things, RF electronics and spectrometer of the MRI machines. Then CDEC Kolkata and CDEC Trivandrum, they are basically they have developed the software part of the MRI machines. And so ultimately, uh, we have developed the magnet, they have developed, Samir has developed the RF part, CDEC has developed the software parts, and then it will be integrated at Mumbai actually. So the government so the main objective of this project was actually to make it affordable and make it a sustainable. So make it a sustainable. So first you make a R&D model through R&D demonstrations basically, and then transfer this technology to the industry. Okay, because it's the indigenous technology, so transfer it to the industry and make, and ministry is going to help the industry in basically commercial production of those machine indigenously, because as I told you, they are imported. So first of all, it will have be a huge reduce the import cost. Okay, and in India we can use in a more efficient way, in a sense that uh, uh, because a lot of things we produce here itself in India. Okay, like the materials, we can locally resources many materials here itself. And we are also looking in that entire MRI machines, what are the components that needs to be built here itself, because there is a large number of component needs in the MRI. What kind of materials, which basically what kind of materials we can manufacture in India in a more eco-friendly manner. Okay, or which are being built already built in the industry. Suppose it needs a lot of stainless steel, lot of aluminum materials, so they are actually uh, mm, used by a lot of industries in a very eco-friendly manner.
Yes.
Now, government has also asked, ki how can, so one is that manufacturing cost, then manufacturing, so energy you are consuming during the manufacturing of each and every component. Then you are testing testing all these components. You are making them workable. So all this journey will consume energy. You are transporting from another place to another place, one place to another place, because you will fabricate in somewhere. Your site will be different. Maybe across the India it will be. Maybe you are fabricating in Delhi and you will be installing the machines in all parts of India.
Yes.
So in MRI machines, one of the major energy goes. basically when you make it workable. So the MRI machines works at, as I told you, minus 268 degrees centigrade, and there needs a liquid helium. So liquid helium need now to generate the liquid helium, you need to spend huge amount of energy.
Okay.
So in the MRI machines, almost a 1500 liters of in each MRI machines, you need a 1500 liters of liquid helium.
Okay.
So that's a huge amount of energy. So government has also now asked us to build where the magnet can be built without no liquid helium. So
Okay.
that means no liquid helium. Is it a very challenging task? It's a very challenging task to make it, but it has to be. Ultimately, that is the directions we are doing in that research on this direction, so that we can make basically we can reduce the consumption of liquid helium, because that takes a huge amount of energy to produce that liquid helium.
Yes.
So by that way, government is putting a lot of efforts in these directions to make it a very sustainable and very viable product, in
Yeah.
environmental friendly product.
So it's
Yes.
really good to know that government has taken a lot of initiatives in this direction. And also, my last question to you is, so my next question to you, sir, is what would be the future prospects of indigenously designed MRI machines, and what role does AI play in it?
Okay. So there's a two. I'll give in a two segment. So first is that uh, what is the future prospect of indigenous machines? So if you can recall my first one, that India in India we have a 2 or 2.5 machines per million of populations.
Yes.
So to make it a 10 machines per million of population, or to make it a 5 machines per million of populations, you need the 10,000 machines in next few years.
Yes.
Okay, which is only possible when you have a in-house productions, because it is not possible through import, because it will be huge import, you have to pay the import cost. So you need to have a indigenous development, and it is also not like one company develops. So you need a multiple basically commercial production facilities in India uh, who can make indigenous machines. So government is putting in these directions, because when Indian companies, or it will be manufactured in India, the cost will go down. When the cost will go down, then you will have a more machines actually. Then you can have a machines in tier three cities or public health centers. Basically, you can put
Yes.
the in the public health centers, because so the government is in fact the present government, which is the mighty, which is funding this project also. They are also uh, have that kind of a plan key to make this machine more affordable, and in fact they are ready to give this technology to the companies who are interested to make it. Okay, so the companies are also interested to make it. So I think that already is in advanced stage, that kind of a basically industry. And so it will be not a typically, it will not be kind of a we have developed it and you build it, just not as technology transfers, because these are huge complex machines. So the industry has to be trained. So there has to be a, so government has asked us to do a hand holding to the industry. So that means next 5 year, probably we will be working together with the industry, and then we'll basically train them in that period, in next 5 years, so that they can start, they understand the subject, they learn everything, and then they basically start
Start
producing the machines,
manufacturing. Yes.
manufacture, commercial manufacture
Yes.
of these machines. So it will increase actually uh, the the distributions, which is presently screwed actually. So you can put machines in the public health center. In fact, another thing is that we should have a, because when the machines, the field is MRI machines, you listen बोलते हैं कि 1.5 Tesla, 3 Tesla, all this. So more the field, more is the cost, more is the energy footprint, basically the carbon footprint. So if you can put at least some smaller machines having a smaller field, magnetic field in the public health centers, basically public health centers, then you have a wider basically access to the healthcare system. So government is putting in that direction also, whether we can make it a much cheaper, much smaller, okay, so that to have a wide access to this healthcare system. Now coming back to the AI, AI
Yes.
play a big roles in MRI actually in now. So AI plays not only big role in a imaging, it also playing a big role in the reducing the carbon footprint, because you imagine one machine, suppose you need a half an hour for a scan or 40 minutes for a scan. Suppose you can reduce that scan time by half. Suppose you can finish one scan by 15 minutes. That means per scan you are reducing energy, okay, because
Yes.
the machine will run for 15 minutes.
Mhm.
So AI is playing a huge role in basically reducing that scan time of a patient.
Yes.
So which runs for a 1 hour, suppose, or 40 minutes. You can do that same scan within a 15 minutes, maybe something, or 10
Wonderful.
minutes, or maybe. So that means if you can reduce the scan time of a patient, so you can drastically reduce your energy consumption, because during the scan, your energy consumption goes up in MRI machines. So AI plays a big role in that kind of a basically reducing the energy footprint or the carbon footprint. Another thing, people have a quest for a more and more field. So people in the metro cities, you will see that 3 Tesla machine, people, the company will advertise the diagnostic centers. Now suppose with the AI, what you can do, you you use a low field MRI, maybe 1.5 Tesla, you create an image of almost similar like 3 Tesla image. So that means you don't need to build a 3 Tesla MRI machines. You are basically using a one smaller field of MRI machines, and using a MRI, you can create an image of almost which 3 Tesla machine gives. So by that way, you can also reducing the cost, because 3 Tesla machine means it will be more consuming more energy. Its products during the production also. That means when you are manufacturing the 3 Tesla machine, it will consume more energy. So suppose if you are making a smaller field of magnet, okay, which
Yes.
will which takes less energy during manufacturing, which
Mhm.
takes less energy during operations, and then using AI, you are basically enhancing the field quality, the image quality, and almost not exactly like 3 Tesla, but almost similar to 3 Tesla. So
Yes.
AI plays a big role actually in clinical imaging, and there is a huge number of researcher working on this, basically how to optimize the scan time, how to reduce the scan time, and how to use a low field MRI magnet, and using an MRI create a high resolution image. So that's, I think, that efforts are going on, research is going on, people are doing actually. Companies are now, you can find the commercial products of that kind
Okay.
of a.
Okay, that's really wonderful. So, sir, now I come to the last question, but one of the most interesting question. Please share with us what the young entrepreneurs should do to build a sustainable Bharat.
Yes, this is a good question, and a good concluding question actually. So, uh, you know, sustainable one of the sustainable Bharat, basically. So that means it is a very big term, sustainable. That means you build everything, you design everything here, build everything here with a very energy efficient systems. So with a very minimum carbon emissions. So it needs a lot of innovations basically, and especially when you are talking about the clinical diagnostics, a lot of innovations has already happened and it's happening. So entrepreneurs actually they needs to do a lot of innovations, especially country like in India, where the healthcare facilities are very city centric basically. So it is in metro cities. So to have a wider access of populations to provide the healthcare access, if you can give a point of care healthcare access to the health primary health center or something. So if you can generate a some kind of a diagnostic tool which is which can be easily operated by which can be easily built in India, which can be easily operated in India, considering the power situations. So it needs a lot of innovation. So I think now the generation is very crazy about the innovations. So the entrepreneurs basically they have a lot of scope for the innovations in the healthcare industry. And next big thing is the healthcare, because people needs more and more healthcare tools
Yes.
basically.
Yes. They are
So the
needed.
technology, they are needed, because that is the, and healthcare industry, so always there will be demand for the healthcare industries. So entrepreneur needs also a commercially a viable system. So if they can build a basically any healthcare product, and they can put innovations, it will be huge commercially success in India, because the country like in India with a huge demand. So if you can, so there is a huge scope of innovations for the entrepreneurs to make it affordable healthcare, to make it sustainable, and that is only possible through indigenizations. That means you can do indigenizations, and then you can make it is more affordable, and more affordable means more accessible to the people.
Yes. Yes.
Okay, and when more affordable means more less energy, that means you have a less
More sustainable as well.
carbon
Yeah.
sustainable approach. So I
Yeah.
think it's a huge entire healthcare industry is basically going through now. In fact, last many years, last 10 15 years, a lot of innovations are going in the healthcare industry. And so it's a I think this would basically the, so there is a lot of scope for innovations in the healthcare industry is still open.
Yes.
And we have a huge demand in, because because most of the people are deprived from the basic healthcare
Basic
and the
care
special
impact. Yeah.
basic care, point of care
Yeah.
basically. So I think make it affordable, make it sustainable with innovations and indigenous, which is only possible when you do indigenizations. So that
Yes.
is the, I think, my final
Wonderful.
comments on this one.
Yeah. Very
Final
rightly
comments on
said,
this one.
sir. Very rightly said. In fact, we need innovation in the healthcare and to make it more sustainable. And it was great talking to you and listening from you what is being done in the MRI machine, and especially how crucial it is and how less a number of people in India have access to it. And it's a great work you're doing. Your team, you and your team is doing. Our good wishes to you, and we hope in the near future you come up with good indigenous machines and solve the healthcare crisis in India, the problems, healthcare problems in India. Thank you so much, sir, for being at our Ecotech Talk. Thank you, sir.
Thank you, Shrestha, and thank you, exneco, for giving me this opportunity to speak in a different forum.
Yeah,
Most of the time, we speak to the mostly the scientists, engineers, or
yeah,
some faculties of the. So, thanks to you, many thanks.
yeah.
It's
Thank you,
nice
sir.
talking to you. Okay,
Thank you.
thank
Yeah.
you.